Audio test. 1, 2, 3. Sounds okay. Let's get started. And by started, I mean... Started, I mean we make our plan for the day. So, welcome, ladies and gentlemen, to the Discourager of Hesitancy, where we build stuff with the least number of dependencies possible. And we are doing compilers as a variety day on Fridays. And there are no dependencies. You need a compiler. That's it. C++ 17, standard library stuff. That's it. That's all. Last time we talked all about UTF-8 text and how we're going to support that out of the box. It will be a configurable item to turn it down to something else. But I guess maybe backing up. Get your beverage ready for the day, whatever that choice is. And last week, the compiler group was pretty well attended. If that's the case, I may switch to 2 compiler days per week, especially since this tokenizer generator and parser generator I want to build up are super reusable. So we will see. We'll see. Javest, how's it going? I am doing great. How are you doing? Welcome to the compiler stream. Good to see you again. So, for anybody watching the YouTube video in the future, the first thing you do with a compiler is you need to be able to walk forward 1 character at a time through your text. And we have different kinds of text. There's ASCII text, where each character is defined by 7 bits, so basically numbers between 0 and 127. There is what we call Latin 1 encoding, which means it's 8 bits, and it's ASCII plus we got the extra bit, so it's actually values between 0 and 255 for some extra common characters in the English-speaking world. So, where did I go? I did get it already. So, we will also be supporting UTF-8. So there is a Unicode standard for this number, means this letter, called Unicode. But there's different ways of encoding Unicode. The most popular on the internet is UTF-8, which is a variable width character. So certain characters only have 1 byte, certain characters have 2 bytes, and certain characters have 3 bytes, and some characters have 4. Good as well, thanks. I'm doing some client web dev work this weekend. Okay, so let's see here. Are you using, I preferred Vue.js, but I believe that React is winning over that one. So maybe you're doing some React, JavaScript, HTML, CSS. I don't know what else goes on in that world anymore. I didn't like web development personally. But working on a project, always good. Making money, always good. So last time we got the UTF-8 support for ourselves. So when we're walking through our regular expression patterns, we can understand them as UTF-8 characters. Now, the next thing we need, let's see here, looking at the journal. We started going down this compile a text pattern, regular expression, into a non-deterministic finite automata. And as we went down that road, I found that I just needed so much infrastructure from my sandbox. So I kind of went through this road once before, figured out how it all works. And instead of recreating this stuff from scratch, I was like, let's just copy paste most of this They're basically small pieces of information that I need to build up the NFA. So the NFA is going to contain one root state and a list of all the states in this NFA. And then each state will have a set of characters that it allows. So inclusion rule is basically a chunk of characters. It's either one character or a range of characters that are all contiguous. An inclusion set is a bunch of these chained together. A state will have some of those, as well as some additional flags and whatnot. And the NFA just has one root NFA state that splits down into all of its children. It is compiled, but again, we just copy-pasted and modified this stuff into our current project. So that's where we left off last time. So today, we should have enough pieces now to start walking through our pattern. So the day is the 9th. I think next week we might do, actually, let me check. I finished week 7. Okay, so next week, I think we'll write some scripts to get better stream stats. Total code is not useful. It's not as useful as we might hope. It is a useful measure on the gross sense, I guess. So tasks. Iterate over regex pattern. Building NFA. HTML, CSS, and JS for this project. No Reactor backend at this time. Okay. Yeah. At that level, it's more manageable, I think. When you start adding more and more frameworks and pieces, it becomes dependency hell. So I've always dodged it as best I could. What's even happening when you type something in React? Like, what's happening on the CPU? Nobody knows. Because the people that wrote React were already buffered by layers of abstraction from the CPU so many times, there's no way that they know what's going on. Not in detail. I mean, we all know JavaScript is an interpreted language. It can get, byte compiled down to something more intermediate, just-in-time compiling. I mean, each of those is a layer of abstraction on top. Running inside your browser, who knows what virtual machines it's running. So, too many layers between me and the metal. I don't like it. It feels unnatural. Okay. So yeah, for the beginner, we're walking over our text as UTF-8, and we need to turn a pattern into a non-deterministic finite automata. What we're trying to do is break a big block of text into words. It's just like reading, English or something. The spaces and the punctuation means here's a different symbol, a different thing that has meaning. And we've got to break ours up into text. Also, as a caveat, writing a tokenizer is not rocket science. You do not need a tokenizer generator. I'm writing a tokenizer generator because I think it's a fun, interesting problem, not because it's needed. Once I've written it, I'll probably reuse it a lot. I like React, but I totally agree with you. Yeah, I mean, the things that React or Vue.js enable feel good, but yeah, there's too many things between me and the code, or between me and the machine. So, well, good luck. I'm going to stream of consciousness, run things unless you have a question, dive right in, and then I'll answer it. But I'm just going to stream of consciousness code and explain as I go. So that's always step one of a compiler, is to tokenize your text. You can write your own tokenizer, dead simple, put it in a loop, walk over each character, decide where to go, depending on what the character is. It's not hard. But I want something that I can reuse, and this is a fun problem for me anyways. I like the NFA, DFA transformations. And I've had some unique ideas. We may have to write up into a technical paper when we get there. So that's what we're working on, is a piece of code which compiles to read in rules. So let's look at the rules. I think I have a test. Dot tokenizer. So each token has a label that I can call it. So this is a new line, or white space, or a code comment, right? And here's a token ID. And this is the list of actions that can be taken. So with the X, we discard it. So we don't keep this new line character when we run into one. We discard it. We don't care about new lines, except that we need to be able to report errors on the correct line, which is why there's this L here. This says, mark us as we've got a new line. And that's it. The pattern is, give me a new line character, and I'm going to expand that out into new line carriage return and new line carriage return, all as different options. So that's actually, this is called a special class in a regular expression. For white space, we just discard white space for this example. And it's a \s means white space. It's the same thing as saying space tab plus, right? So either a space or a tab. And we're actually going to add a special character here called the non-breaking space, which when you copy paste from the internet, you get these all the time, and it breaks so many parsers. But we are going to handle it correctly. If you paste a non-breaking space into UTF-8 supported code, we will count that as white space. So that's that character class. Here is a comment, // anything that is not. So this brackets means anything, and if the first character is a raised hat, then it's a not. Anything that's not a new line character, as many as I want. So this lets me add comments at the end of lines, right? Line comment. Now we could say everything up to a new line and put the line character, the line action here. Those would be very valid as well, but it's not necessary. Two different ways to write the same processing. Then finally the token ID. This one we will keep, and then we have a range of characters, capital A through Z, and then capital A through Z with or underscore. Right. So these character classes basically means anything with A's and Z's that are all capitals, as long as it and underscores, as long as the first character is not an underscore. That's kind of what this means. And it has to be at least one character long. We would keep those in our current tokenizer example. So that's what we're heading towards, I think, is we're going to walk through this string today and try to build examples, build a thing, build NFAs. Basically turn this from something human readable, something the computer understands and can execute. So that's our plan. So if we go into our source directory, we have an NFA compiler that we started stubbing out. Nope. Pattern to NFA converter. I didn't want to overuse the word compiler, I guess. Which is pure static, which I don't like. I don't like that it's static. So I think we're going to make it an actual thing. Pattern to NFA converter. basically for multi-classing, multi-threading reasons later. If we're all running in one static object, multiple threads hitting the same static functions and things, it's not pretty. If we separate the data, say here's the data we have, then everybody can run in parallel and maintain their own data, save for the... These are not intended to be copied or assigned, these converters. So that's great. We will compile. That's like the main function. NFA out. I'm trying to decide. I'm trying to decide what I want to do here. I don't want to pass in the NFA. So I guess we just have a function that says, give me the NFA. Therefore, we need an NFA there. Void compile. Scan pattern. And our text buffer. This text buffer is not from a... It's a fragment. We're going to hand in this string here and set it in the buffer. This will make a copy of this pattern. So we don't take ownership of this string you pass in. Create our own buffer to hold it in a copy. And then we're going to build up this NFA. Anything else we need? Scan pattern. We have a list of fragments and a... Well, I don't think we need to pass in the buffer. All right, I'm going to look at my old sandbox code. Old sandbox. Don't think that when there's a stack of fragments, bookkeeping elements, this will all make sense in a little bit. Scan pattern is never called anywhere else, so it is safe for me to remove that buffer pointer.
Oh, you didn't miss the meeting? Yeah. You didn't get out. Okay. Oh, geez. How do you hear?
We need some bookkeeping for all of this. We're removing this buffer. I don't need a buffer, do I? I think NFA already has a text buffer. Yeah. Let me think. I can do that. We want the NFA to own the buffer. Buffer does have a clear function, which doesn't need to be called actually. Now we no longer need to do that. Let's set pattern. The NFA will contain a buffer. We don't own this buffer now. Set pattern. NFA. This is one of the things I really wanted to clean up after my last write. Make sure the ownership of things was much more clear. Okay. So here, n underscore buffer dot copy text. And we need a label as well. Yes. You know, we might as well make text buffer have it clear as well. That way things are cleaned up when we expect. Then when we ask for a string of it, we can make a copy. So whoever requests the pattern from the NFA must clean up after themselves. Okay. Create our initial list of fragments that we're going to expand. If we scan the pattern without creating an error, out to NFA buffer. Const text buffer. Buffer. I guess we have to end the whole buffer. It should have no effect on anything. Turn the address of our buffer. We're not allowed to make changes to it. Pattern. Word. Okay. List of fragments. We scan through the pattern given our buffer and the list of fragments we're building up. The reason we did this. We will get to this later. We just want to do the scan for now. Scan complete. We want to come back to that as well. Real clear here, NFA compiler. Oops. Let's just log note. Scan failed. Okay. Which brings us to the scan. We have ourselves a list of fragments here. And we have a stack. And we're going to push this fragment list onto that stack. So what's going to end up happening is we're going to have a list of fragments here on top of a list of fragments here on top of a list of fragments here. As we need a new element on the stack, we'll create one and throw it on top. And when we're done with it, we'll pop it off. So by the end, we should only have one thing left on the stack. This is important because we're going to do parentheses. Keep track of parentheses, we need the stack. Okay. Initialize. Okay, we don't skip all that. Set root, add state, merge. That's going to be a useful one. But scan pattern is where we're looking at now. So very similar to what we did before. We're going to walk over this buffer. For UTF-8, character reference C, is that what I'm calling it? I guess you can call it that, that's fine. Which accepts our buffer. Oops, matter. Okay. Let's do this. Let's break this up a little bit more. Do you want to set the NFA? Or do you want it to just create its own NFA? Let's just create our own NFA. NFA I don't think takes anything. Okay. Which means we also don't need to pass that in. The only reason we pass in this fragments is so that we have them to process afterwards. This is our initial fragments list. Okay, I think it simplifies things nicely. Where we go, file, rule token pattern. Okay. So for this character reference in underscore NFA 0.2 buffer UTF-8 char dot is valid, I think. Is valid. UTF-8 char dot NFA. We're going to walk forward one character at a time. Okay. In an inclusion, this is a special flag. So let's copy this and I'll talk you through it.
Yeah, I know. Okay.
Okay. Then let's simplify it as much as we can. This is a mess. Okay. This is a one-liner. This is a two-liner. Okay. All right. We cannot shrink it as much as I would like. That's right. So let me just clean this up and then we'll talk through what it means. Anybody have big plans for the weekend? I don't think I do. These days, most of the time, I watch the small kids. My wife goes to a farmer's market where she sells baked goods. They are very tasty baked goods, which is one of the reasons I weigh what I do. This is where I become very, very happy. That I wrote such good notes in my comments. Okay, so here's what happens. This flag, we have to process it first. What happens is if we're in a text, let's see, where's my example? Here. If we hit one of these square brackets, we're going to flip that flag and say we are inside of an inclusion list. Okay? So everything we're doing in that block processes this stuff in here. So this underscore, it handles it. There's special rules. For example, this minus sign means A through Z. So if you want an actual minus sign, you have to put that as the first character in your inclusion set. Okay? So all that special handling happens there. This, if it's the first character in an inclusion, means flip it. It's not. Anything that's in here should not be the next character. Okay, so this is an exclusion. Okay? So all of this says, if we're in the first letter of the inclusion, and the first thing we see is this character, we flip the logic for that element. If we're inside of a range, so this A through Z is a range, right? So if we hit the first character, we just like, okay, let's put the character in. Then we see that minus sign, it says, oh, flip this flag to say we are inside of a range. Then we know that the next character is special. And we make it into a range. If we're not at the first character, and there's a minus sign, we put ourselves inside of a range and escape, like in here, right? Anything that's not a new line, the escapes are specially processed. So we hit this backsign, and we're like, hey, flip the flag that says we are inside of an escape character clause. If we're inside of an escape, then N is a special word. Right? \n means new line, new character. So we say we're allowed new line characters and return characters. If it's a \s, we can handle the space, a tab, and here's the non-breaking space, right? Ampersand non-breaking space. So here's where we actually add that support ourselves. A \t means a tab, so it's actually not that special. D means a digit, so anything between 0 and 9. Otherwise, if we're inside of an escape, these are the allowed characters. I don't actually see. So we have to be able to escape a square bracket if we want a square bracket inside of our inclusion set. Oh, here we go. So a backslash says escape the next character, so we flip the flag and move on. Here's the close of the inclusion group. This is where we clear the flag and say, yeah, we're done with this inclusion. We hit an open bracket, we hit a close bracket, we're done. Otherwise, it's just a character. Oddly, I don't seem to have processed backslash square bracket. We probably should add that. If we're in an inclusion and we're in an escape and the character we hit next is that, then this just becomes part of the set. Okay. So hopefully that makes sense. All of that is processing. Hope you're having a good day. Silly style question. Why UTF-8 character reference and STD list NS, yeah. Okay. Lisp gamer, why UTF-8 character reference and a list of NFA fragments. Okay, so the UTF-8 character lets us walk through any text buffer and check every UTF-8 character is well structured. So let's go ahead and sidetrack into this. Scratch buffer. Oh, I was going to add this code to my .emacs. Hold on. Add it here. Sorry, easily sidetracked. Okay. So scratch buffer. A UTF-8 character starts with a 0 and then some number of bits, 2, 3, 4, 5, 6, 7. That means 1 byte character. These are all the same as ASCII 7-bit. Same as. If we see a pattern 1, 1, 0, 1, 2, 3, 4, and 5, that means this is a 2-byte character. And the next byte has to start with 1, 0 to indicate continuation. 1, 2, 3, 4, 5, 6. One more. This is a 3-byte character. More. There's another 4-byte character. These X's are the Unicode encoding. Okay? So what a UTF-8 character reference does is it says, point at this text buffer, tell me where in the text buffer I'm pointed, how many bytes am I, and then when I say advance, it moves forward the correct number of bytes and figures out how big the next character is. I guess I need to put the rest of the byte in. Huh? Okay. So that's what UTF-8 character reference is. So UTF-8 character reference contains a pointer to a buffer. So the buffer itself never gets manipulated at all. The buffer is completely static and locked. It's const. So I should put that in const buffer. We never manipulate the buffer. You'll see that that's not quite true where we are, but it will be true in the generated code. It has an offset from buffer, and it has a number of bytes in UTF-8 character. And it has some convenience methods for dealing with UTF-8 characters within the context of that string. What this means is later on when we do UTF-8 string references, we'll be able to reference a character plus a whole bunch of... We'll be able to reference sections of this text buffer and never do a string copy ever. So that's why UTF-8 character reference. I don't want to copy strings in the generated code we're going to end up with. List of NFA fragments. So what we're going to do is we're going to walk through, and every time we understand a piece, we're just going to put it on this list and not worry about the relationship of these elements to each other. Then we'll go through what I call the reduce phase, where we say, all right, you, what's your action? You know, if you're a 0 or more, then I have to take the previous element and put it under it. And we'll manipulate this list quite heavily to build up the structure of the NFA. So hopefully that helps explain where we're going. JTL, yes, the farmers market. I have a number of family members in a band who play very well. So if you're in the region, which I think I've got, gosh, I don't remember, Sweden? I don't know where Lisp Gamer's from. Yeah, most of you are probably not going to be in the area, but the band is very good. Do you, JTL, do you have a web page? I can always plug for you. You sell CDs? You should sell CDs. Oh, you guys play mostly covers, don't you? So yeah, Lisp Gamer, welcome to the chat. If you have any other questions, let me know. If I didn't answer your questions fully, or if I just misunderstood the question, let me know. I'm happy to pause my stream of consciousness coding and explain anything to any level of detail people are interested in. Nope, no website, no CDs. Okay. Well, they're pretty good anyways. And I'm not biased, I promise. Even if 60% of the band are related to me. I'm jealous of their musical talent, though. Okay. Okay, so that's handling, we are inside of square brackets, everything that happens inside of them, and how do we break out? That's what that block is. Let's go back to where we were stealing from, NFA compiler. We still have to process an escape character here. And it's a little bit more involved. Let's just grab all this. We'll do the style changes as we go. I think that's what we need. We'll talk about it as we go. Let's do some style cleanup. When I was first playing around with all this stuff, I was pretty heavily in the every bracket on its own line. Now I'm not in that camp anymore, so every time I borrow old code, I feel sad. All right, we'll talk through every detail of this code. Actually, we'll probably be logging things in ways that will help see what we're talking about, which would be more efficient than me trying to explain. But we'll do all of it. We'll do it all every which way. But for now, I have style issues. In case you couldn't tell. So yeah, for those who are new to the stream, we're building a tokenizer generator. This is not necessarily the best or right way to do it. You can write a tokenizer yourself trivially, or near trivially. I just like this problem. It's an interesting one. It tickles all the right challenge centers of my brain. So I am curious to see if I can make it faster than other things, but that all is after we get functionality. We'll talk about every one of these just a minute. There's a lot of cases. And we're going to add more, actually. There are features that I want in my regular expressions. There's others we won't ever bother with. All right, almost to the bottom. We'll talk through every single case. Apparently we copied an extra one. Okay. So, if we are not in one of those square bracket areas, if somebody has flipped the flag that says we're escaping a character, we have to handle that here. So if we got \n, we have Linux, which uses just the new line character. We have Mac, which uses the carriage return. This may be an old Mac thing. I think modern Mac uses the \n like everybody else. And Windows is still off doing their own stupid little thing. There's still the old carriage return line feed. That all goes back to the days of the teletype. You had a tape, and there was room for 7 holes in it. And when you type, it would punch holes in it to match the ASCII pattern. ASCII 7-bit pattern comes from these teletypes. And the carriage return was a special line that would say, don't print a letter, just move the printing carriage back to the front. And then the new line would move it down. So literally, and also on your old typewriters, right? Hit the enter, where the enter key is now, and it would line feed, and then you'd hit the lever on the side and the whole carriage would slide back to the beginning. So it used 2 actions. Well, Windows is still stuck back in the teletype days. And yeah, Mac just had to be stupid weird on its own as well. So, when we get this character, we're going to build a special rule as if you had written this. It is either an N, a new line, or a carriage return, or it is a carriage return followed by a new line, CRLF. So that's what this whole chunk does. It builds us as if we had typed this. This shorthand becomes this. So that's all this code is. Add a carriage return, add a new line, concatenate, end the group, reduce it, etc., etc. And done. If we get a \t, that's an easy one. It's just a character for text. 0 through 9 is easy. \s, again, space, tab, or non-breaking space, so that you can copy-paste code from the web and not blow up your thing. AK Elements is rating with a party of 2. AK, welcome to the stream. Thanks for dropping in. Dot is a special character in regular expressions. It means match anything. Otherwise, we assume it's just any old character. And it doesn't need to be escaped. So if you've escaped something that's not one of these, you don't have to escape it. But it'll still work. It's just a warning. So, shout out to AK Elements so that anybody can follow him. He's been working on a game engine of his own. Onyx, is that right? He was doing a node-based, graph-based materials editor for a while, and I think he's on to materials handling now, doing some physics-based rendering. So if you want more high-tech stuff, go give AK Elements a follow. He's a very consistent streamer from Wednesday on. So yeah, welcome aboard. Today is Compiler's Day. We're doing a Tokenizer generator from scratch. So we're writing our own regular expression engine to turn our text regular expressions into NFAs. Wednesday through Saturday. Awesome. Wednesday through Saturday, take a regular expression, turn it into an NFA, a non-deterministic finite automata, And then we'll turn that into a DFA and use that to generate our tokenizer code. Caveat to everyone, you can write a tokenizer by hand easily enough. This is unnecessary, writing a tokenizer generator. But it's a problem I like. So guilty pleasures, I'm allowed to do this. And what we're going to do is we're going to take that DFA and we're going to use that to emit code that understands how to tokenize your text for your programming language. So that's where we're at. We're working our way through UTF-8 last week. This week we're actually crunching the pattern, hopefully, into an NFA that we can print out. At this point, we're kind of copy-pasting a bit of code from an old sandbox and tidying up style and talking through what it all does. So if we're walking through our pattern and we see a backslash, we're just going to flip a flag and say, hey, the next character is escaped. If I see a dot, we just match anything and move on. If we get a square bracket, we flip a flag saying, hey, we need to go into a special state called, are we in an inclusion? And then the special character, the first character in an inclusion can be a special character. So we have to flip a flag saying the next character we encounter might be special. We pass in that. End bracket, we handle that inside of our inclusion handling. So this would be an unexpected character. You either need to escape it. Unexpected character bracket does not close an open inclusion or exclusion. So you either need to escape it or find the matching bracket. Or means you take whatever's on the left or whatever's on the right, and you have to try either one. So I can say, for example, a pattern A or B, and it'll try A first. If it's not A, then it'll try B. That's all it means. And these can get, of course, complicated. You can have, 0 through 9, XYZ, or B, right? So it'll try to match all of this, and if it can't find it, it'll pick the B. So that's all the OR means. Alternation. We try the left, then we try the right. That's all. Okay, this question mark I want to expand on this time around. So let's add ourselves a note here. But all this does to do non-greedy modifier. So what this means is whatever the previous thing is, I want either none of it or one of it, 1 or 0. So I can have a string like this. I could say my pattern is A or A question mark B, and what that will match is AB or just B. So the A is optional. That's basically all it does. And again, A could be a much more complicated thing, right? So this is A.C, whatever this expression is. So the question mark just says the thing before me, 0 or 1 of them. We'll come back to this in a bit. The star means 0 or more. So it'll keep trying. It'll say, hey, can I get another one of these? Can I get another one of these? And as soon as you can't get any more, it bails out. That's fine. But we're also allowed to have 0. The plus means 1 or more. So you have to have at least 1, and as many as you want after that. So these are all useful options for, I call these cardinality tests. And here's where that stack becomes important. When we open a parentheses, it means do this first no matter what the other rules of precedence are. So just like in math, right, where you have 1 plus 2 times 3, that equals 2 times 3 because multiply happens before addition plus 1, so that's 7. But we can change it if we say 1 plus 2 times 3, and now that's 9, right? So the parentheses change the order we evaluate things, just like in math. So we're going to open a group and we're going to put in a new empty list of fragments. This is why we have this list of fragments going onto a stack. This one is going to handle everything when we open the group, all the way until we close the group. Now, if the stack is empty, it means that we have a closing parentheses that we're not matched with. We don't have an opening parentheses. So that's invalid. It's broken. If it is, then we pop this whole thing off the top. We say, take that list of fragments we grabbed from here to here, and we're going to finish processing it, basically. It says, take that list of fragments, chunk it down to a real thing, and then add it to do the bookkeeping round, cleaning that up. Okay, that's all that is. So parentheses handling, very useful. Otherwise, the character is just a character. Put it on our list. That's it. So that'll walk forward through I don't want to talk about reduction yet. Do I want to talk about reduction yet? Maybe we skip that for now. Actually, let's just return. So, anywhere there's an error, result. Anywhere there's an error should be a result as well. So let's do log error. Oops. So those are two ways to get invalid. That's a warning, that's fine, that's also fine. Those are just warnings. Okay. So we have a few ways we can break it. Otherwise, we're good. I guess one other thing, if not result, so if we get an error, let's just fail. Okay. So that's it. We're just going to walk through the string and assign each one an operation. Do I have a way to print an NFA fragment? That one real quick. Oh wait, we have the start state. Okay, so we can put this. For each item in our fragments, item log. I think NFA state has a log method. Yes. All right, let's try this. Let's see. Clean debug. Ugh. Integer with different things, that's fair. C standard int. All right, compile one more time. Get all the errors, warnings out. Yeah. Count. Okay. There we go. No warnings. I may seem a little obsessive about cleaning up old warnings. I've been in large projects where the warnings were allowed to build up and build up until the signal to noise ratio was unusable. So I am pretty opposed to letting those things build up. There are some I will ignore, but not very many. Okay. We are going to ignore all of that. We'll put in a test case. Pattern to NFA converter.hpp. Make sure it's a big file. It's not. Okay, then main. Compile. And compile does what? It returns a. No, it doesn't do anything with it. Yeah. Compile rule ID, token ID, and a pattern. So let's just do A, B, C. So the letter A followed by the letter B followed by the letter C. This is called concatenation. If you have two things next to each other, it just means they're next to each other in the text as well. Back in the old days, they used to have dots to say concatenation. Thankfully, we got rid of that because the dot now means other things. And that should automatically log a list of the fragments. Oh, no, sorry. / source builds debug. Okay, we'll give it a -p, even though PV project. Did I tell it to do that? I said don't process args. I guess we need to clean. We'll do it. What's going on here? File clean and debug. Oh, yeah. Okay. Part of our refactoring, coming back to my desk. NFA compiler, you are correct. It was not defined here. We are not doing things that way anyways. Okay. Let's see how that gets us along. Scan pattern fragments. Scan pattern fragments. Therefore, I didn't change the signature here. Because we no longer need to pass in the buffer that is maintained elsewhere. Cannot convert Did I delete a star on accident somewhere? This would be that. That sounds more right. Yeah, start state. Oh, I love a good refactor. Let's see. Oh. That's just me getting halfway into a thought and stop. Unused parameter rule ID, token ID. I think NFA. Not the NFA, I guess NFA state. So these are the different operations we talked about, right? Match a character, include any of the following chunks of exclude the following characters, accept any character, alternate, so take A or B, 0 or 1, 0 or more, 1 or more, we talked about those, and a group operation. We're going to add some more in there, but we're not there yet. So the NFA state has the rule. So we set that. It's public. Okay, we can. Oh, we're doing that here basically, but we can hack that in real quick. Item point to rule ID rule ID token ID token ID. Get rid of some warnings. Okay. Now, last time we ported over a bunch of that code. Are those definitely NFAs? Yes, this is going to definitely be an NFA. But I think I need to steal these two functions from my old code base. Now I remember why I needed them. When I get this UTF-8 character that equals n, and we are inside of an escape, we need to tell our inclusion that this is the character that triggered it, but this is the value we're actually looking for. That's why we had the value overwrite overload from the old code base. So we need to go get that. Back in my old sandbox, compiler core. UTF-8 character reference. No, not reference. We want the inclusion rule. Right? Value override. Yep, those are the ones I didn't know if I would need them. I think I need them. So let's go ahead and steal those real quick. So we commented it out, commented that one out. Turns out these Fusion rule. And then I just commented them out. So yeah. It's easy to put back in. So then inclusion set. Here's the other things you commented out with those value overrides. Let's skip the update buffer for now. Okay. And that's it as far as that goes. I think they banned Signal and YouTube now. Who bans Signal and YouTube? Void set override value. And 32p value. That's kind of like what this bump up and bump down do. We talked about that last week. It basically changes the value we're comparing against without losing the character reference we're using. Set override value, or yeah. All right, we're getting closer. The glorious state over here. Oh, I see. That's terrible. What are you gonna do with yourself without Signal and YouTube? Actually, you know what? I don't even use Signal. Signal Messenger. Come to think of it, I don't use a messenger unless I'm forced to at work. Like Slack, I think was the last one I used. But I've used like the different ones, I guess. Comparison of integer expression of different signedness to really? Wow. Okay. Well, that's awkward. Why would that be that way? It should not be this. Don't think one real person uses Signal. Okay. The pitch is you explain to your friends what's ETE and they say, go. They say add me on Telegram. Champion of typing over here. Yes, good old Telegram. You know what, though? They keep coming out with all these new applications, and they're all the same. Like, none of them are any better than, like, what was it back in the day? What was it called? RCQ, no, I forgot the I don't know, chat programs, for all they're being new over and over again. 2C string. That's what I want. They don't do anything new that I couldn't do before. IRC. There we go. Good heavens. What's the thing that has a Q in it? ICQ? ICQ? I don't remember. Oh, yeah, ICQ. There we go. For the young kids in here. Boom. Cross-platform instant messaging client. Oh. Developed by the Israeli company. AOL. Man, AOL. Talk about old school. Shoot. 1996. Good heavens. How old have I gotten? When did that happen? I wasn't watching. Somebody should have told me. There are days when I wonder if we just should go back to Usenet. Ignore those. We'll get to the reduce in a second. Once we prove that we can walk through a pattern and get what we expect out. I really did do things differently, didn't I? Okay. Bite size. Yeah, you can see on Wiki our social media magnet bought it in 2010. So many places where we reduce. Probably good. ICQ Netscape browser. No, Netscape browser was not good. We did not go back to those days. We need to go back to the days of early Chrome before Google became evil. Alta Vista search. No, I used Dogpile. Dogpile would search like 9 search engines for you at once. Give you like the Ask Jeeves, Alta Vista, Yahoo. Yahoo used to be a search company. When was it? Was it mid 2000s, early 2010s? There was a study that it basically said Google, Yahoo, and whatever Microsoft was using at the time. It wasn't called Bing back then. They're like they did an internal research of all 3 companies to see what search engines the search engine companies were using, what the employees at the search engines were using. And everybody at Google used the Google search engine. Nobody at Microsoft used the Microsoft search engine. And even the Yahoo search engine, people were like, yeah, only like 5 or 10% of us use this Yahoo search engine. It's pretty embarrassing. GNU adjacent or Linux kernel adjacent spaces use RRC and mailing lists. Yeah, I need to. So I know Emacs will fire up a Usenet. I can probably browse old Usenet servers with Emacs, but that's another one of those things I just never got around to. Is that not? We might as well grab these over here, right? We'll talk about what they mean when we get there. We'll allow this stuff, so. I didn't mean Netscape was good. Good. Yeah, do you remember back in the days the Microsoft browser would always just slightly break all of the HTML standards and nobody's page would render correctly unless they targeted it from Windows, and then brings back good memories from my youth. Yep, back in the days. Let's suppress our warnings. Unused parameter, fine. Oh, that's right. We changed it from being a static thing to holding its own state. Which does raise a question. Whose job is it to clean up? I don't think the patterned NFA converter is the owner of the NFA. Google does it sort of now. V8 drops tail column elimination that is part of ECMAScript. Oh, joy. I think the book I was studying was from before that. No, you don't remember how bad Netscape was? Like maybe way back in the day, it was okay. It was certainly better than the Microsoft offerings, but when Firefox came along, whoo, we jumped ship from Netscape just as fast as we could before Firefox became a bloated, disastrous mess. As to now, as far as I know, there's a port of Guile scheme on web. Oh, jeez. What a world we've come to. And you know what? None of those things have made my life any better. Like, I just want a stripped down, bare bones browser. I don't want it to offer me AI answers when I start typing. Okay, back to where we were. We were testing this. Scan complete. Match the character A, match the character B, match the character C. Those are all next to each other and completely unrelated to each other. We will get to that. So let's test some other patterns just to see if we're still okay. Let's take any X, Y, or Z and ABC. Actually, let's pass a pattern in on the command line. If argc equal greater than 1, give me argv1. Else usage vb regex. Actually, this is not optional. I should have put brackets. There. Now we can do all sorts of testing of all sorts of features without having to redo any of that. Okay, so XYZ ABC, one of XYZ followed by A followed by B followed by Z. Nice. We can change that by saying XYZ or A, which good gravy. There we go. X, Y, or Z, or A, followed by B or C. So actually, this is the same as if I wrote it with the A inside here. Does that make sense? Or A, B, C. So this one will not print what we want because we're not doing reductions yet, which means that it hits this parentheses, enters a special state saying, hey, we're working a new pattern from here. We hit this state, and instead of returning that as a single fragment, we're not reducing that down to a single fragment, and it's just going away, disappearing into the ether. So this will not work. We can do other things. Let's see, or let's do an exclusion. Anything which is not a quote or the letter Q. And it's good old bash to the rescue. Single quote. Oh, okay, fine. There we go. One of XYZ, yes, I agree. Or not anything that is not a quote or a Q. I need 0 or more. So we're getting basically a list of things, but we don't know how they relate to each other. This is definitely not right. Because inside of quotes, the pipe can happen. There we go. Alternate this. So which one happens first? This one? Does the alternate happen first? Does the not Q or quote? That's where reduce comes in. Yes, I remember Firefox beat Netscape pretty bad back then. Yep. You should quote those, shouldn't you? Yeah, Netscape. Yeah, yep. I catch up eventually. I'm a little slow sometimes. But the ideas are here. So we could do \s, \d. Oh, interesting. Oh, I know why. Because the character, so we take \d and we basically replace it with a range. But when I tell it to give me a string, it's still referencing the D and not the 0 through 9. So that's fine. I'm not happy with it, but what was the other thing? \n. Maybe here at the end we can put a \d and see if that prints out better. It doesn't. And again, the \n is getting a similar issue, and that doesn't bother me too much. So this S is 3 things now, right? There are 3 values. One is the space, one is the tab, one is the non-breaking space. This is the carriage return or the new line. This is 0 or 1. So do I want to fix that printout? I probably want to fix that printout. All right, let's go fix the printout. NFA state. Is that true? So it really has to do with the... Thank you. Log. See, this is where these things are happening. Right, so go to the inclusion rule. That's where the print is happening that's wrong. ToString. So you see we're using the two reference strings that created the range. We don't necessarily want to do that. Value override. Oops. Start C.2C string. Okay, let's just tack a little bit more in here. Override value. Okay. Bool m_score is overridden. Which most of the time it's not going to be. We don't care about the performance of this particular piece of code at all. So we don't care if there's a bit of extra bookkeeping here. What we care about the performance of is the code that we're going to emit, we're going to generate. This is not overridden, but value equals true to C string. If it's valid, do certain things. If m_score is overridden, we're going to do different things. Okay. Whoa, oops, what was that keyboard shortcut? Jeez. Can I get on home row here? There we go. It's overridden, we're gonna do something else. This is the default behavior. I only ever intend to override with a single byte. Assert. If we ever run into this, I will fix it. How about that? We're going to cheat for now. M_score byte size. It's greater than, it's not equal to 1. Equals, we assert that it has to be equal to 1. New character array of 2. Results of 0 equals _ value. Results of 1 equals the null terminator character. And now we're done. Only I could hit the space bar hard enough. There you go. Bool. Apparently that's not a type. Not sure why. It seems like a perfectly valid type. Should be fine. Assert. Okay, I guess we need to tell it about assert. It does not know about assert. And now when we print, hey, that's definitely not right. Interesting. But 1 of 0 through 9 works fine. Okay, the other problem is new line space tab and the other thing are also special characters. NFA character reference.
Which wall? Right here.
There are times I want to know what the characters are. There are times I want to have the character itself. Therefore, to C string bool escaped. Give ourselves a little extra room all around. It escaped. If value equals new line character try to make this as readable as we can. Tab. I'm fine with the space of non-breaking space that needs some special attention. The non-breaking space is what's thrown off right now. Pattern. Reassert. Byte size equals 1, that's fine. Give ourselves the extra byte just in case we need it. Zero x2. This is the non-breaking space right here. Else if m value equals this lovely number here. Okay. Result. Sum. 0. Backslash. Okay. I'm going to use a special character for that, I guess. Results of 1 equals n. Oh, no. Okay, we'll just put it back where it was, I guess. This is fine. Again, I don't care about the efficiency of this. This is just for printing stuff, so not too worried about it. The S expression, base Regex expression, constructors, and Emacs is so nice. Yeah. Yeah, there are times for sure. Comments region. Yep, assert is runtime macro, right. It's enough to tell me that my assumption is wrong. This is just for printing, so I'm not too worried about it. If you ever trigger this, then I'll know what my assumption is wrong. But so far, it hasn't blown up, so whatever that means. Okay, this is not the best, most efficient way for us to do this. Performance of this code does not matter yet. Non-breaking. Let's see, new line, carriage return, tab. I think this is extra. We're going to make non-breaking space a special capital S. Therefore, in our inclusion rule to string true. All right, we're going to try that. Assert is a runtime macro. Yes. If yeah, so the assert is basically a macro which says if n debug is not defined, so in other words, if we're not in a release mode, then test this condition. If it fails, we terminate the program and print out messages. So it's just a runtime macro. That condition finished successfully. Yes. Okay, one of XYZ escaped \n \r to handle that. Perfect. Alternate. Yep. Not a single quote q space tab or non-breaking space. Right. 0 or more 0 through 9. Okay, so our character overrides are working and we're printing reasonable text. So we have these fragments in a list, and there's no structure to it. So we need to add the structure. Oh, we're so close. Which is all about these reduce functions. I could swear once that I had a reference to something. Let me look up one thing real quick. Get operator precedence. Somebody must have a link to it. Precedence table. Okay. So this web page will show up today. No. All right, we will make it show up. this way. Okay, here we are. So our regular expression, I've told you the escaped characters, we have our bracket expressions, we have grouping, we have these, I call these the cardinality rules. Concatenation is an operator. Like I said, there used to be a dot so you'd have to put between things. Anchoring is something we will add. Alternation. So this tells us what order things have to happen in, just like in math. Plus, minus, multiply, divide, exponentiation, parentheses. That has an order to the way we apply these things. Same thing here. Okay? Well, escaped characters and bracket expressions we've already taken care of. We do that as we go. We're not doing that. We are doing grouping, again, as we parse. That parentheses happens before anything else. So here's our cardinality rules. Then concatenation. Anchoring we're going to add in later today. And then alternation. This is the order things have to happen in. So let me just put that in text doc as a note so that we don't have to keep flipping back and forth. I love the web. Escape characters. Special character. Bracket expression. Grouping. Cardinality, which is times plus question mark. We're not doing. I've never found a need in designing a programming language that I have to have this feature in my regular expressions. There's a couple of regular expressions that makes it a little bit simpler, but we're not supporting it. Basically, for those who care, and this means the thing before this, here's the minimum number we expect, and here's the maximum number we expect. So you can have A from 1 to 3, and that would say I have to have 1 to 3 A's. Or you can leave that off and it's assumed to be 0. You could do that and it says 4 or more, which really is the same thing as A plus, right? So these are just shorthands for ways to get numbers of things. If you want, 1 or 2 things, you can do A question mark, right? So we're going to skip that one for cardinality. We're not supporting that. Concatenation means that the things that are next to each other have to follow each other. Anchoring, we do not support yet. Oops. Where did that go? Okay, I see what happened. And then alternation. A choice between 2 things. Anchoring we'll talk about when we get to it. We're skipping it for now. And like I said, concatenation is no longer a dot. It used to be a dot. You had to type A followed by B. Now it's just empty. Okay, escape characters. Oops. Escapes, brackets, groups, cardinality. So, a group will collapse when we finish this closing bracket. So we don't have to reduce that here. We reduce our cardinality, then concatenate, then alternate. We will be supporting anchoring soon. And when we were all done reducing, we better have one thing left at the top. And that's what we return. Okay? So reducing cardinality. Let's do concatenation first. That's easier to test. So let's go to our old NFA compiler. For debugging, I had a lot of print statements and things in here. That's basically it, though.
Please stop. I'm sorry.
Talk about what we're doing here. Okay, we say start at the beginning of the fragments. While we're not at the end of the fragments, we're going to get a next thing and try to step forward one. So basically I want a pair of things next to each other, the current thing and the next thing. And I want to make sure that we're not off the end of the list, okay? So the next has to not be at the end. If that's the case, then we get our fragment from the iterator, doesn't matter. We get the state, so that we're working with the state, and we get the operations. If our current operation is to do a thing, is alternate, then we just move on. Okay, concatenation, it happens before alternation. So we skip over alternations. We skip 2 if this is the case, because this one has not been finished. The next state hasn't been completed. It doesn't have all the information it needs. Otherwise, this is where these fragments come in. The fragment has a state, and then everything that's hanging off of it that doesn't have a finished next. Let's look at NFA state. Let's talk about state. A state has a rule, right? Our operation. It's going to match a character. It's going to match a bunch of characters, or exclude a bunch of characters. So we have a rule, and then we have where we can go from here. We can go out number 1, or we can go out number 2. Okay, so if I have an alternate, both out 1 and out 2 have to have something. I can't have a regular expression that is A or, and I'm done. There has to be something to alternate between. So if you're here, if I'm at the state where I understand that here's an alternation, I've got something in 1, but there's nothing in 2, it's not complete. This rule is not complete. A character doesn't need an out 1 or 2. It doesn't go anywhere next. It just matches the character. 0 or 1. Yeah, so each of these has to be complete. Each of them has a requirement of what outputs have to be defined. So a fragment says, here's all the little ends of undefined things that we've gathered up. We have not assigned. So this is where we patch those. We say, given my current fragment, it has a place where it's going. We're going to patch all of these to point to this thing, to the next state. Okay? That's what that patch means. Everything in the current fragment. This is the list of all the outputs that are unassigned from here. We're going to tell it to point to the next thing. Then we make a new fragment, we append it to the fragments, put everything else inside of it, blah, blah, blah. And then we erase the fragments that were updated and are no longer fragments, but they're now properly set up in the tree as related to each other. Does that make sense? Once a fragment is complete, we can just take the top level state from that tree and delete the fragment. So that's what a lot of this is, bookkeeping around blowing away the fragments and then getting the NFA element out of it before we do that. Okay, so that's concatenation. So it will see everywhere we go to reduce. Now we want to uncomment. So we're going to start supporting reduction, but only for concatenation for the first time. These two still do nothing, the cardinality and alternation. So it will see I'm not going to log these anymore. We don't actually support that yet. So we'll just do frag point to start state log itself. There we go. I think that's what we want. Just to get things started. So hopefully this is making sense. Oh, good old copy paste. Patch frag outs. Trying to copy that before and append. So append frag outs. I told you the fragment says here's a state and here's all the unfinished next things. Patch. When I put a state underneath another state, I say, hey, what are your dangly bits that are not assigned yet? And I'll add them to this list so that when we resolve that, when we patch it, they'll all get assigned at once. That's all that does. So into the old code. Oh wait, I don't have NFA compiler open. And I'll bet patch and append. I'm not sure those need to be in here. I think we can just do it here. We just have these as free functions. There's no ownership here. Yeah, patch and append. So once we get them patched, we append the new stuff, and off we go. Okay, the only thing it supports right now is concatenation, right? A, B, C. So we match A, and then the only place we can go from there is to match B, because they're next to each other. The other thing we can do after that is to match C. Right now the rules and things don't matter. The rule IDs, those will come in soon. So there's concatenation. Now, instead of a flat list of fragments, we're getting the structure. A, then B, then C. So let's do the same for alternation. That's usually an easy one. Let's go steal that. That's going to be very similar. Okay, we're going to get a pointer to the first thing. Then, or not at the end. We get our state, we get our current operation. And if the thing we're looking at is an alternate, then we do the reduction. If it's not, we just skip on. We have to look at the next thing. Is it at the end? In which case, like I said, alternate at the end doesn't work. Actually, this should be an error condition, probably. If we're in an alternate and there's nothing after it, this is just broken. Being on the right. Does this not return anything? These probably should return things. Pattern to NFA converter. Cool. So back up to this concatenation. Bool result. If that's true. There is no error condition for concatenation. Because it's not an operator, it's implied operator. As long as there's two things next to each other, it concatenates. So nothing to check here. This one does, though. This has an error condition. Looks like I'm missing an opening paren somewhere. There we go. If it's an alternate with the next thing, blah, 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 blah. Yes. We keep track of the previous thing because what we're alternating is the previous thing and the next thing. So we update our state. Previous equals the current thing, then we move the current thing on. Okay, does that make sense? Hopefully that's all clear. So we're just going to walk through all the fragments and say, oh, you're an alternate. Let's look at this. The next thing, then we patch them together and say, this alternation, out 1 goes to the previous state, so the thing on the left, out 2 goes to the next state, which is the thing on the right. We patch we add all those outputs to our fragment, and we're done. That's it. Clean up the fragments, those states have been assigned where they belong, and we're done. And keep track of the previous, move our current on. That's basically it. So alternation should work now. And you'll see when we test. Oh. Ooh. Result equals true. Return result. That is fair. Okay. So ABC should still work. Now ABC or E. So we alternate. The first thing that happens is we alternate. We say, is it C or E? Well, is it ABC or is it E? And when we hit the letter C or E, we can accept. So accept is these little plus sign ones here. It means we're done. If we ever stop the string here on B, this string doesn't match. ABC has to hit all 3. Does that make sense? So the 2 conditions are we either find A, B, and C, then we can accept, or we hit E, and then we can accept. Okay? If we end anywhere else, it is not a valid match. So that's what the plus sign indicates. Okay, catenation, alternation, done. Last piece. Again, if I'm like loading through something that you wanted to talk about in more detail, let me know. Otherwise, I'm just going to keep on going. Cardinality. Okay, so we get a pointer to the first thing in the fragments that we're trying to reduce. We get our operation. If it is one of the cardinality ones, in the first element, before we've even started moving, that is an error. Result equals false. And that's it. Result equals false. Guess we just wrap this in more parentheses. Never have enough parentheses, right? Okay, then. So what am I saying here? I have ABC, right, and I can have a question mark, star, and a plus anywhere here because they modify the thing that they come after. I can't have a question mark here because this is 0 or more of whatever's on the left. There's nothing on the left, so this is an error. Okay, so that's what we're checking for there. Once we've done that, we say save the current pointer. So this is the first element. Move on to the next pointer. So now we have 2 pointers, one to the previous, one to the current. So I can always look backwards. Zip through the line. Get our previous and current things. If our current operation is one of these, or one of these, right? Then we say the thing on the left is the previous state, and then shove everything onto the list of open fragment outputs. Erase the fragments that we've cleaned up finally, and we're good. 0 or more. So let's see here. There's actually a very good web page. Like there's nope, not here. Where is it? I'm pretty sure I have it written in here. Yes. Okay. So it's called Thompson's construction. So I'll put this into the chat. This is not the best write-up of the process. The best write-up of the process was this one. This is the one where I finally got it. Let me see if I can share this without losing my mouse too much today. So if we come over here, share the browser, boom. Okay. Concatenation. We're doing that one. Yeah, this is not a great example of how to understand Thompson's construction. This one is much better. Blah, blah, blah. This is it. Converting regular expressions to NFAs. For concatenation, literally just put the first output of element 1 pointing to 2, and that's it. That's concatenation. Or means we take this or element and we say the left is 1, the right is 2. The question mark says either we match E or we move on to something else. Okay, and this one is left open until we find out what that something else is. E star looks like this. E points back to the element it came from, and this thing either points to E or out. So I'm talking about these out 1 and out 2 pointers. This is what they're for. If it's a plus, well, we hit E first, and it can go to this either or. This either or either points to E or points out. These are the fragments we're building right now. Right? We've done the concatenation, we did the alternation. Those were easy to conceptualize, but sometimes these can take a minute of staring at to get, oh, I see. So we come to a choice. We either take the next thing that we find and go that way, and we try to, or we try nothing. In other words, move on to the next thing, whatever that is. But it has to try both. This is why it's called a non-deterministic finite automata. When you get a letter, you have to try one, and if it doesn't work, then we try the other. Okay, so these are the shapes that we're building right in our code here. So let me put those links into the chat. This is the second one, much better. This is such a great resource for, oh, that's how regular expressions work. This is basically how I built this code. Like this told me exactly what needs to point where. Those little pictures right there that I just showed. So useful. And that's all it is. We're just pointing little arrows to the right places and cleaning up our bookkeeping. So that's an error code. And then it should return. Okay. Let's try it. We should build it first. That's going to work way better. When you make code changes, you need to compile them. Okay, there's ABC. There's ABC or E. Nothing different there. But now we can say question mark A. So there's 0 or 1A. So we are either 0 or 1, A or B, followed by a C. And then if this rule number mattered, it would, if we were passing in real rule numbers, state indices, then it would point to where this would jump to. Or we get an E. 0 or 1, A, followed by B, then C. I want to say this is not quite right. We should be able to do parentheses now since all of these features are so important. Okay. That should not have made any difference. That's good. Okay. Things like \d should work. Things like A through Z should work. Actually, let's put those on the other side so that things are a little bit more balanced. This is just a test, right? Match E, then one of 0 through 9, followed by A through Z. Okay, perfect. Followed by anything which is not A through Z. Or a minus sign. Okay. I'm pretty sure I know why that happened. It's probably because of that. Not A through Z. One of minus E. Yeah. Zero or one A and B and C. Okay. Yeah, I think that's just about it. We can also completely mess this up by putting parentheses there. And what it does is it's zipping along, building up this list of fragments. It comes to this parentheses. It says, wait a second, I have to handle this group. So it's going to put a new thing on the list, build up these fragments, C or E. And then when it hits that close parentheses, it says, all right, let's collapse C or E into one thing and drop it right here in this list of fragments. Then it continues on. So either C followed by this stuff or E followed by stuff. A, B, etc., etc. Group. And these dashes are basically me saying, I've already printed this state once. Don't print it again. So I can look at this and say, oh, this points to NFA state, whatever up here, but we're not passing real numbers in the state number. We probably should do that. But we're basically building this structure now out of our regular expression pattern into an NFA with structure. Does that make sense? Everybody cool with this? So let's get the NFA state tracking down. That needs to not happen. Set root is one place where this happens. And then adding states here. Okay, I know what that's about too. Okay. So let's blow away this one. Set root. Is that in here? We've got the fragment. We want to take the state out of it and shove it into the NFA. Cleanup is easy. Just do that. Okay. Just a couple pieces. Okay. All right. This is a pretty common pattern I run into. I always want to clear something. Clean up my resources. Yeah, I'm on NFA, not equal to null. Let me clean up after ourselves. And really, that is the only thing to do. And we can go ahead and throw that in our destructor. Okay. Set root. Set root, add state, add state. So these are basically just copy pastes of what we had before. Except I'm not sure I want to do those here. I might want to do those on the NFA itself. Because right now this assumes that we're good friends. So let's go to NFA. I guess that'll happen here. Set pattern. We have a couple of options for set root. NFA 0.2 to nothing. Okay. When we set root, we say this is a start state. So it's going to properly highlight that state as one of the few places we can begin processing. That's fair. These assumptions are okay. But when we add a state, do it like that. But they're all going to get an index so that when we print them out, we can see which ones those ones are pointing to. I think that's basically it. Let's get these 4 functions into our header. Okay, so that's NFA. So over to the pattern NFA converter. Set root. There. Done. Phew. Do the fragment, return nothing unless we ask for it. Is that really what we want to do, though? Compile. I think I want compile to return a boolean as well. Okay. NFA state has no member named index. That's unfortunate. Oh, state ID. I see. Oh, so close. Okay. In my main function, we compile if it succeeds. Pattern to NFA not NFA NFA log else. Pattern failed. Okay, I think that might be enough. Except for is to what it's called NFA. All right, last thing is ownership of the NFA means we don't delete it, actually. So that one is wrong. This one is fine. Well, it shouldn't need to be cleared there. I basically decided that this was not so maybe clear is the wrong word. Clear. Clear a buffer. Delete each state, then clear a list of states and set our root state to nothing. Yeah, we don't need to clear anything here. But really, it's not a clear as much as a destroy NFA. So if there's an error, then we can destroy the NFA. There, done. Otherwise, we do not destroy it. Pattern to NFA converter NFA. Keep forgetting to actually give that a note. It is trivial. Pattern. Image word NFA. Could be null. But will not be null if file returned true. Okay. Scan complete. Here it is with all of the state numbers. So here's state 3. We have 0 or 1A followed by whatever's in state 3, which would be a B, right? Because we've already logged it. So this is a repetition. Cool. Last piece, a little clean up. Boom, done. I think that's it. We can now compile patterns into NFAs. Woohoo! All right. We'll come back to that someday. Two. Normalize inclusion sets. Okay. The code is there, but we don't want to put this in just yet. Okay. I think if that's all, we have all the pieces for NFA. But I want to add 2 features. There we go. Full scan. State 0. NFA state 0 is the alternate. 0 or 1. A, B. C is an accepting state. So the parens means it's a start state. This is the only place we could start. E, one of the things. This properly references back to an already visited state. Okay. There we go. Whew. Well, let's close this one. Okay, this one. Journal. Boom. Add anchoring. Add non modifiers. Okay, mostly copy paste of NFA compiler from old sandbox. Pattern ingested and turned into an NFA. Oh, there's one other thing I want to add to NFA as table instead of tree. Okay, so I think got that done. Let's save our work. We did make some changes to that. Yeah, we've added a lot of code here. A lot of it copy pasted, but it's fine. There. Okay, the NFA right now. When it logs its pattern, which is good. Then it logs each state underneath it. And each state increases the indent of the one below it. Therefore, that's a useful way to look at NFAs often, but I would also like a table view. So let me think. Just rename it log tree, log table. Table will be a little bit more complicated. Actually, it won't be that bad. Logging the tree still works. So scan complete is still log and complete. Scan failed. Boom. Okay. So you can see there's some duplication. And in bigger NFAs that we're going to get, these references to other areas are going to be a lot more. So, and the indents can be hard to follow sometimes. So what we will do, log table. We log the pattern in the same way, that's fine. But I want to know, let's see, what do we need to know? Is it a start state? We need to know that. This is the rule ID, token ID, so don't worry about those just now. Those will be what we feed in later. So we need to know a state ID. State ID, rule ID, token ID. That's 3 numbers. Then our action. 3 numbers and a string. Operation, maybe argument. Then it wants to know what next state and next state. Is that right? Let's start printing things. Four. Every state in states. Let's just do this fast and dirty. We want modulo status for state is start. If so, sure, we'll work with the star, otherwise nothing. We want to know if state can accept. Then we want to know state ID. What else do we want? Op. So we're going to helper function here. Static database state, static star op of a state operation. Operation name. Then we want to know put params in here, or not params, separating separators. Is this a start state? Can it accept? State ID, operation name. Let's put params in here for this one. Get a character array. State point to conclusion. Set. Oh, just called conclusion. It's not equal to null. And equals state conclusion to string. Temp is null. Anything otherwise, use temp. Temp not equal to null. Okay, so temp. That's if there's an argument at all. Then we need two more. We need n modulus 0 3d or n modulus 0 3. End of table. Oops. Oh no, this is it. That one equals some amount. I basically need to take state, point to out one. Conclusion text. That's one thing we have to know before we start the logging. Star. Actually, not. It's just a character array of out one string. We'll make it sufficiently large. Up to. $127 10 equals the string character if state point to out one not equal to null, then we got everything we need there. s print f into out1 string n 0 3 e given state 1 state id. Same thing for 2, basically. Okay, is that everything? This will not look good. Okay, shockingly, that was not the worst thing ever. Table. Okay. Our table looks like garbage, but it's okay. State 0 is our start state. It's alternate. There's no information there. Alternate should be 1 and 5. So what happened to 1? I may have made a mistake. Somewhere. 2. We're blowing away our own work there. Okay. Alternate goes to 1 or 5. So state 1 is a 0 or 1 of 2. So that's A. Or jumps to 3. So it's either 0 or 1A, then 3. A can only go to 3. 3 can only go to 4, which is C, which is an accepting state. This alternation goes to 5, which is E, which can only be followed by this, which can only be followed by this. Perfect. We have table output. It looks like garbage, but it is table output. We should clean up the table output so that all the columns are fixed width. But sometimes this is going to be easier to read than the tree view. I think they both have their place. Not top, not node, top. Okay. The way we build it, state 0 will always be the start state anyways, but that's not a big deal. We know we can only have one start state, and it will only be one character. Well, let's do this. Let's print out a header. Start. Accept. State ID. What happens after state ID? Operation. Argument, pattern, text, value, left state, right state. This is not going to look good, and that's okay. I could just close that up. There we go. Okay. So the way to get these columns to line up is to find out what's the widest thing in the column, and then we'll build a format string for it. I need to get rid of these quotes. Conclusion to string should get the escaped values. I believe it does. Is that true? \s. Yeah. White space tab, non-breaking space. So we're getting into okay. Oh, except space itself. Okay, here's a new TFA character reference. Here. How do I tell myself it's a space? Honestly, the only place it really probably shows up here. Oops. I don't know how I feel about that. At least I can see there's something there. One, two, three, four, five, six, seven. Take the time right now to build this right. And we'll look. It'll be easier to debug the other things later. Okay, so what we have to do is take each header and the contents of each possible column. So we have 1, 2, 3, 4, 5, 6, 7. 7. Except that 1, 2, 3, I already know the complete width of. Start and accepts these headers will always be wider than any indicator we put in the column. So int column width 0 equals the length of start. column width 1 sets. Column width 3, go back to 0, 1, 2, 2, 2. 3 is operations. Value. These two, well, yeah. There's 5 and 6. Will be equal to the same column width 2. Because they're just state numbers, they'll always be the same. Column width 2. The largest state number we have is the length of our late state list. Into num states. So our width will be however many digits it takes to represent num states plus an n. So while num states greater than 0, column width 2 gets bigger, num states divided by equals 10. Just peel a digit off. One, two, three, four, five. I'm just gonna hard code it. Two, three, four, five, six, seven, 8. If column width is less than state ID, which is 1, 2, 3, 4, 5, 6, 7, 8, 7. Let's go 7. Column width 2 equals 7. Okay, so that's the column width of those ones. Lastly, value. Which depends on whether there's an inclusion set or not. And the operation. Now, operation's not too bad. Value is a little bit painful. This is actually very inefficient what we're going to do, but it's for logging. It's not actually important to our performance, so it's fine. This is only logged when you request it, so it's not a big deal. This, go through each state, and we ask, what's the length of the name of the thing? This string is not generated, it's a static string, so there's very little overhead here. if lin is greater than column width 3, column width 3 equals lin. Now I'm going to convert that logic. It's silly. And then lastly, if column width 3 is less than 1, 2, 3, 4, 5, 6, 7, 8, 9. Column width 3 equals 9. Column width 4 is a little more painful because every time we ask a inclusion set for a string, it generates a lot of strings and it's not pretty. But this is only for readability. It does not matter the rest of the performance. So const jar star temp equals if state inclusion not equal to null, that matters. And we generate a state inclusion toString, which we have to clean up at the end of this. This is part of the pain. We're going to generate every one of these twice. Once to see how long they all are, pick our width, and then once when we generate the thing. Could I cache these temporarily? Yeah. Again, performance not my top concern right here. Plan equals sterling temp. Over. Lastly, if column width 4, wow, column width 4 is less than 5. 4 equals 5. Okay. We now have a width for every single column, which means this format string can actually be formatted instead of what we've got. Format. 10.4 should be plenty. Printf into format. The following: modulus negative. Okay, modulus minus modulus d s. I think that's mostly the pattern across the board. Except for this one, which is n modulus 0d minus 0d. We'll try that. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 4 after, 2 before. Okay, then we just give it column width 0. 1, 2, 3, 4, 5, 4, 4. 0, 1, 2, 3, 4, well, 5, 6 are solved up here, yeah. 5, 6. 6 columns worth of formatting. Here, use that format string. Actually, let's test to make sure we did this right. Just log. That would at least know what our format string looks like. I agree. There should definitely be semicolons in weird places and commas in places. Okay, so here's our format string. 587. Good heavens. That feels not like it should. That's definitely not right. 11. I guess that's the what, 0 or 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, so that's correct. 5, which is this one. This is 5 characters wide. 7. Where's it getting 7 from? Well, either way, this goes here, and there. This one doesn't actually go there. It's more complicated than that. So let's see. We can leave this here. We'll come back and fix that later. Okay. Where's that format string we're creating? Why would we do that there? We would not. That would be a silly place to do that. Okay. Okay. 5, 4. Where is that 7 coming from? That's huge. Our number of states is like single digit. Oh, because of state ID. 1, 2, 3, 4, 5, 6, 7. That's fine. Okay, good. So I think they're ready to use this. Format. Let's rename format to line format. Because we're going to have to do a header format that's slightly different. And it blows up. Of course it blows up. Why would it blow up? This is my format string. Five, 8. Oh, okay. So close. D. D and D. In theory, that should help quite a bit. Hey, there we go. See, now I'll avoid columns line except for our header, and that makes no sense, those numbers. These ones fit. Although I don't like this formatting at all. These ones are just outright wrong. Still, we're much closer. Four, 5, 6, 7. Oh. Well, there we go. So close. This is looking almost usable.
One culture.
I guess state ID can be that wide. It's fine. These state IDs are complete rubbish, though. So what happened to those?
Yeah.
We can actually do that differently. One. Oh. Nope. We do need to do it this way. I lied. Okay. Oh, no. This number, which we get from here, needs to be here. This needs to be a special format. Our state ID format equals, let's make it a big thing. We'll come back to that shortly. That one. So column width 5 and 6 really never mattered at all. Printf into state ID format. This thing given column width 2. State ID format. Oh. You know what? That is fair. This doesn't need to be that big. Okay. Except for this blank spot here, which should be filled with spaces. Two. So index equals space. One string, sub call with 2, finish the letter string off. Okay. You're getting there. Some more questions in the comments. Fine, but just know, happy to slow down anytime if anybody has any questions. Okay, so the spaces are still not quite right. That is a little odd. Oh. Uh, 2, 3, 4, 5, 6. I'm filling this with spaces. Oh. Plus 1. To count for the letter N. There we go. Okay, so this body of stuff is awesome. It's ready to go. We just need to fix the header. Which I guess are left aligned. Alright. Our header format. Similarly large size. Negative, modulus. So it'll escape the percent sign so that when we use it the next time, there'll only be one. It reduces that. Remember the S. Since these are headers, 2, 3, 4, 5, 6, 7 columns. Column width 0, column width 1, column width 2, column width 2, column width 3, column width 4, column width 2, column width 2. Header format, give it start, accepts, state ID, operation, value, left, it's all of that line up. Okay, our table is almost done. 1, 2, 3 lines left to add. How's everybody doing? I know that printing tables is not the most exciting, but like I said, if we make it, the more readable we make it, the easier it'll be to debug later. We will find issues with our NFAs, DFAs, have to go back and look at the NFAs they were generated from. So the more readable, the better. Last piece, char line, and 24, I guess. Last thing we want. How are we doing? Still awake? I'm still awake. How are you guys doing? Just about got this table thing beat. Int offset equals 0. Line at offset plus equals vertical bar, then not a vertical bar, no, and a dash. While int count equals 0, count less than column width 0, plus count, and line at offset plus equals new hyphen. Colon 1. Colon 2. Colon 3. 4. 2 and 2. Okay, log top equals new line character or end of string character. What am I saying? of our line. See how that turns out. Okay. So close. Except this one's short. So close. 1, 2, 1, 1. That's what that should look like. Oh, left and right need to get one more in there. One, two, three, four. Aha. Oh, so close. One off there, one off there, there. It's the operations one that I'm missing now. Everything else should line up perfectly. Operation. For some reason, the length of the operation is off by 1. Try it everywhere else. Let's see here. That's column 3. Column 3. Not sure why this would be a +1 here. Doesn't make sense to me. But it works. Okay. Ooh, no. No, it was not that one. It was state. I was wrong. This one. Now it will work better. Okay, this is our NFA as a table. So the only start state is state 0. State 4 and 8 are in accepting states. So if we get one of these characters, we know we're done. And these characters, we know we're done. Here are the operations, and here's where they go to. We alternate between 1 and 5, so we can jump to 1 and try that, and we can try 5 if that one doesn't work. When we hit state 1, it's 0 or 1 of this thing. If it's 0, it'll go straight to 3. If it's 1, it'll hit this one, and then 2 should go to 3 with no choice. 3 goes to 4, 4 goes to 4 is accepting. So this is the end of a run here. 5 is if we jump on this alternate to here, E has to be followed by 6, followed by 7, followed by anything that's not these characters, to 8, which is a white space, and we're done. This is also accepting. Woo! Okay, so we can view our NFA as a tree or as a table. So let's go Add that in. NFA options to print as tree or as table. Go. Okay, so anchoring or non-greedy modifiers. Honestly, the non-greedy is probably the easiest one, question mark. Let's do that one next. Okay, for this one, let's share back to the page I shared out earlier. So here, let's see, can I find a good example? Regular expression, non-greedy modifier, blah, blah, blah. Okay, star 0 or more. If I add after that star a question mark, so question mark after star plus or question mark means don't be greedy. Only take what you have to, but don't take any more. Now, I don't have much use for this in a programming language design, but it would make some types of regular expressions easier for people to write potentially, and it's trivial to implement because non-greedy, blah blah blah. So the rule is eat up as much of the string as you can using these. If it's possible, use these. However, so they're greedy. Actually, we could probably make this a leisure greed. However, if you put a question mark after these greedy operators, they become non-greedy, which say try to get out first, then if you have to, consume more of what you need to. Normally you'd have to do backtracking, but since we're doing a Thompson DFA, all we have to do is try the shorter one first. So when we do question mark, we first say, is there one? If there isn't one, then we do the other thing, right? If we say non-greedy question mark, it means, is there anything else we can consume that isn't this thing? We'll try that first. Then if we have to, we'll go back to look for the one option, which really means that out one, out two, all I have to do is swap them. That's it. So let's stop sharing the browser, get into the code. So in our pattern to NFA converter, reduce cardinality tests. We're keeping track of previous, and we have a current. So if our current op is 0 or 1, this is the question mark, then we have to ask, is the thing before this Let's see, do we get next? Yeah, this only modifies. Let me think. We can do this a couple of different ways. One is being very, very clever here. One is just marking them all and cleaning them up later. Current versus previous. So for current operation is 0 or 1. So the question mark. The previous state operation. Oh, do I have previous op? I do not have previous op. Let's do this. Previous start state op. Which means whoa, oops. That's not right. Okay. We take the previous start state and we can do something to it. We could mark it as non-greedy. That's fine. Interesting. Oh, yeah, that's reasonable. Let's go to NFA state. I'm going to add a thing to it called bool is non-greedy. Will have no effect except CPP. Okay. Is non-greedy equals true. And we don't have to do anything. Don't have to do anything except that in this one case, we leave previous alone and advance current anyways. Plus plus current to advanced one, and then continue the loop. I think that's it. Leave previous alone, advancing current. Then up here, yeah, I don't have access to the states in that way. Add state. If state point 2 is non-greedy, state not 1, state not 2, auto 10 equals state not 1, state not 2 equals 10. So if it's non-greedy, we just swap. There it is. Okay. That's literally it. To make an operator, a cardinal operator, like 0 or 1, non-greedy, we just swap the order that we try the paths in. That's it. No backtracking needed. So go to this thing and hope this works. Log okay. This is close, but it's not quite ready. We do that. If it's a 0 or 1, 0 or more, 1 or more, wherever the operation name thing is, we're going to also ask is non-greedy. If it's non-greedy, it'll be a minus, otherwise it'll be a plus. That's what I've decided. And NFA, see where we do the table. Do a very similar thing. Operation is going to get at least one more. Oh no, it's still going to be, oof. Okay, it's 9. That's plus 1 in the header and in the line. Nope, not here. So column 3 needs, oh, that's 2. Modulus S. We can make that a character. We're only gonna handle one character. Therefore, column 3 plus 1. Down here where we do the op name, state point to is non-greedy. Where it's non-greedy, it's a minus, otherwise it gets a plus. It expects a character, not a string. We should do the same thing here. And that should do it. Okay, if I can remember where to put all the semicolons. Hard rule. Statement may fall through. Oh, I kind of thought that was the point of the logic. Oh, no, not this one. You're correct. That one is breaking, falling through. Run it. Okay, all of these are greedy. So if we just change, oh, what? Okay, I already don't like that. It's because of the table. Anyways, we only have one here, so we make it question mark. Now that one has a minus sign. Oh, but it did insert a state when I thought we'd skipped over that one. Oh dear. Okay, so we've got a couple of issues still to deal with. One in logging. All right, find tar C equals a space. If state on. Okay, well, cannot type. Equals NFA state operation. Or we do that. Character equals plus if state point two is not greedy, C equals minus. Char C, char greediness. That's going to be a little bit more readable. There we go. And this is wrong, but hey. something we should test also. Log tree, log table. Okay, tree 0 or 1 has a minus, 0 or 1 has a plus. Okay, so this should not look like this. This should not look like this. This second one is being added in when it shouldn't. That is just a modifier on the previous thing. So if we go to here, where we do greediness things. Current start state equals previous start state. We don't have to do any of that. Fragments erase previous. No, fragments erase current. N equals current. Fragments erase temp. Delete current frag. Have to remove it from the whole process, right? There we go. Now it's 0 or 1 non-greedy. Or greedy. Okay, so let's make this greedy. This greedy. Plus. No, let's go star and plus here. Now things are getting light for me. Good night from Sweden. See you tomorrow? No, I don't stream on Saturdays. I'm too busy. Too busy watching small kids. But thanks for dropping in. Hopefully you learned something. If not, well, ask more questions. Also, good times with nostalgia, talking old tech that kids these days don't know how good they've got it or how bad they've got it. Not sure which it is. Yes, thanks from Sweden. Catch you later. So these are greedy. And we can make either one non-greedy, like this. It did not work. Plus question mark. Now there's 0 or exclusion. It changed the order of something. Okay, the 0 or more became non-greedy. But not the plus. That became wrong. They rearranged things incorrectly. Huh. That's odd. I wonder. What have I done? Also, as a test, 2 then 3 for this one, which is greedy. So it should be 3 then 2 when we make it not greedy. 2 then 4. That's definitely not right. It should be 3 then 2. It might even be, oh wait. Alternate, 0 or 1. What? B. Yeah, so A is just getting added first. Then B, then C. So that I think is correct. So this is the, well, let's do something more simple. Well, that's awkward. Okay. You can have this, it goes to state 1, which matches the character, or this just accepts when you get nothing. It tries nothing, and if it can't find nothing, then it goes. Let's put B in here. 0 or 1 of A, then go to B. After an A, also go to B. Okay, so if we put this in, it should go to look for B first. So this one should point to B. If it can't find that, then it finds A, which then goes to B. So 1 looks for B. If it can't find B, it goes to 2. And then it looks for the A, which then looks for the B afterwards. So yeah, this is correct. That's the question mark. That seems reasonable. We go with plus A plus B, which means 1 or more A's followed by B. That, of course, blows up, and I don't know why. Let's put a star in. Star, 0 or more, greedy. So we first try to look for A. If we find A, we go back to 0. A, until we can't find another A, then we go to 2, which is B, which accepts. So that looks right. Non-greedy says, look for a B. If you can't find a B, go to 2, look for A. If you find an A, go back here. And keep looking for a way out sooner than others. Okay, so something's wrong with plus. What about plus question mark? That works, oddly. So 1 or more non-greedy. Goes to 1, looks for a B. Oh, 1 or more. 1 should look for a B, which accepts. It should look for an A first. It has to have 1 A. Oh, no. Yeah. Uh-oh. Am I not formulating with plus right? This one's crashing, so let's look at this. Run. Here's our trace. Corrupted stack. I don't want to hear that. One or more. It can't find a B. Okay, I see. It looks for B first. No, it should not look for B first. This should go to 2. And then 2 should go back to 0. Beginning to suspect that the copy paste of plus is not right. 1 or more. Previous fragment has a lot of things that go out. It needs to point to the current state. One or more. One or more is behaving more like 0 or more, so one or more. Where's my little fragment pictures here? One or more. This doesn't look right to me. These two look identical. Current start state out 1 equals previous. Patch frags out previous out current start state. Current frag out pushback and current start state out 2. Fragments erase previous, delete the These two are identical. Why are these two identical? This one should be different. 0 or more is working fine. 1 or more. Push this thing. E, which was popped. Patch E out S. Okay, so this is E, this is S. Push fragment E. Previous fragment. Let's see. Should previous fragment. Oh, wait, this is not what I want to modify. This one. Right. So rev equals e, current equals s. That's e dot out patch s. Yes. When we push e dot start. Was our previous fragment. S out one, current out one. Did we erase previous or current actually? Delete previous because this one is kept in where it is. We literally shoved current under it. Is that what we do? Question mark. Those two lines. Question. That means we have to delete the current fragment, not the previous fragment. Oh. Wait. Okay. So if there's a 0 or 1, try to find A. If you can't find it, go to 2, which is a B. If you do find A, then find a B. Okay. If you have a question mark, first look for a B. If you can't find a B, go to A. If you find A, go to B. Okay. Star, I think, was working. Look for A. If you find A, go back to 0. If you can't find A, go to 2. So that's 0 or more. Yep. And then if we do this, we look for B first. If we can't find B, then we go to A, and then go back to 0. I gotta check the phone. I don't think the other people are at home, so just a minute. Someone is home to take care of it. Okay, so that's that. Plus, it blows up. It still blows up. E start. Let's start at 1. Now I'm just running into a which element do I delete? So far, debugger has been less than helpful. And on Bing W, stack dumps are always useless. I've never got anything useful out of them. I'm sure there's a way to, but I'm not there. All right, have to think about this. Current state out equals the previous thing. So if we have one or more, it points to the previous thing. Then we say the previous thing points back to this thing. Does that match with my picture? E is the previous thing, the circle is the thing. This thing goes to the current state. So those, there's that loop. Previous fragment push current start state out. E out. Yes. Okay, so that's the patch. What's the append? Fragments erase something. Move on. I think that's it. I don't. I mean, we can set a breakpoint. Pattern to NFA converter line 327. $327. 372. What? That's not right. How come I cannot set? What? What is this thing doing? All right. Restroom break while I think about what I've done wrong with my life here. Okay. Here we are. Snack in hand. There is a significant delay. Interesting. So how do I figure out what plus has done to kill me? The debugger's useless. Zero or more. Try to find nothing except yeah, this means match the empty string. It doesn't do anything useful, but it does construct the table, right? Hmm. Tries to find nothing. Okay, there's something about the plus that I'm missing here. It's probably something simple. The current state is the plus. The previous is a. So we're saying plus goes back to the previous state to check for more stuff. And then the previous state and everything that it can lead to all need to point to the current state. That's the looping part. That's fine. Then the previous fragment. Picture. Take E out of the equation. So that's that. Create a new start. Push. Onto. Oh, wait, what? What push means? Push a new fragment. Okay. Patch E out. S. Patch S. Okay, I agree with that. Mhm. Most of this I agree with, code-wise. Okay. Let's go way back in my sandbox. Way back. Where was that? No, that's probably not the right place for it either. Compiler core Bay. NFA compiler.cpp reduce concatenations. Reduce cardinalities. 0 or 1, 1 or more. How does this compare to this one? Current state at 1 equals previous state. Patch the fragments. Patch previous frag out current starts. Current fragment out push. Did this ever work? Did I? Okay, here's the question. When I was using this and testing it, did I ever use the 1 or more operator? That's a fair question. I do in 2 different places. Is this not line for line the same thing? Start state, patch, previous fragment out, start state. Those I agree with. Current fragment out, push back, current out 2. Which is the same as this line. These are the same. Fragments erase previous, delete previous fragment. Did this ever work before? Puzzling. Okay, well, non-greedy operators were supposed to be easy, but we've uncovered, I think, a long-running historical bug in my sandbox, where plus is behaving like a star. And was wrong. See, I like that table view. I think that's somewhat easier to read than the tree view. Okay. What if we do something like this? Instead of this. This doesn't have to be a break anymore, or continue anymore. This can be break. Since we're no longer incrementing current, same way. What jump? Oh, it crosses an initialization. Ridiculous nonsense. Oh. Alright, when did my auto formatter decide to start automatically inserting stuff that I don't want? Not my favorite. Oh, there we go. It at least ran. So, state 0, character, match an A. Then, we must go to state 1, which matches, which tries to go to here. If it can't find an A, then it's just done. Hey, that looks more right. I do not know what this means. Okay, so 0 or 1 goes to state 1, where it finds a character A. Whereupon it goes to state 2, it tries to go to A, or it accepts. See, the 0 or 1 should not be here. So there's something wrong. The plus works. Well, does it? That's a plus B. A plus B. Where did the plus go? A plus B. Okay, so there's still issues here. In this one. Hmm. Everything up to there I'm reasonably confident in. Hmm. All right. In this case, E. Let's see, what can you see on OBS? So if we go down. So here's the case we're looking at. S is our plus. E is our previous. So we're going to hit the previous thing, and then it's going to say, can I try again? Or do I move on? So the previous thing, which is A, so S, is going to be pointed to by, so the plus is pointed to by our A element. Patch, our previous fragment gets told about S. So that's the patch. Then previous segment so my problem, I think, is this push. So let me think about it. Oh, where'd my mouse go? There it is. For some reason, if I have a Twitch window open, OBS loses track of my mouse. Push. A new fragment. Here's where we do another push. Let's go look at concatenation. Like I said, they used to use the dot operator. Let's go look at concatenation. And now this keeps disappearing. Yeah, it can't work like that. I'm thinking this line is my culprit. If we go to concatenation, push. Oh, make a new fragment. Oh gosh. So if we make a new fragment given what's in the picture. Our previous start state. We append our current state out one. Oops. New frag with our current start state out one. We don't need to do anything about next. Erase current, delete current, current equals next. Okay, so that's not quite right. I think prev equals current plus I think those are just wrong. Fragments, insert, current, and new fragment. Oh. Wait a second. Insert at current location, the new fragment. Auto next equals current plus 1. Erase current, delete current fragment. Previous equals next. Nope. Previous equals current. Erase current, delete current fragment. And then current equals next. That wasn't right. That converts NFA state to a fragment. And frag outs. Next frag. Okay. So next. Oh wait, no. It's all the bookkeeping. And frag outs needs an NFA fragment star. From and to. Okay, so current start state Here's the next thing. Previous thing equals the current thing. Erase the current element because it's already redone somewhere else. Delete the current fragment. Then advanced current. Okay. New frag out. Oh, not a pick. Push back. Okay. And yeah, it just blows up. Wonderful. And it did not blow up. It does not think this is an accepting state, so that's always awkward. Dumps. Okay. Okay. We can. Hack this back in. I think I just never once ever used a pattern that required one or more that I didn't actually provide the one thing. This is what we had there. Do that. I agree. Make a new fragment. Oh, patch. Can you do the patch? Patch. Previous frag out with the current state. Yes. We push a new fragment of previous start. And then we list and we push back. Oh, that one is here. Agree with that. Put that in. Oh, well, previous can't equal current because we're going to erase current. Next is that. Okay. Next equals the next thing. So now it's the previous. I think previous just stays the same. Okay. It still doesn't claim it can accept, which is a little awkward. A plus B definitely has issues. First we grab an A, then we go left to 1, which has a 0 or 1. It first tries to go to 0. I can't find A. Still want to know how I got away with plus not working right this whole time in my sandbox. Down here, insert at current or new fragment. Hmm. Patch. Wait a second. First thing we do is patch. Make a new fragment. We add this. Still does not say it's accepting. Nope. Character A down to here. Says 0, 1, 1. Okay, here's a question. Instead of this, we are scanning our pattern. Find this character. We are pushing back 0 or 1. Do I have a previous in here anywhere? Nope. Okay. Therefore, stacked up. This is a linked list, so st list. Can I get the back element? All right, I guess I better get the phone. Just a moment. Okay, all back. Okay, so here's what we're gonna do. If stack dot top size is 0, that's an error. Question mark. Start of a thing. We can go up better messages later. Result.
Agent chips.
Okay. So that's the first thing we're going to do. We'll do that. If that's okay, then we ask what comes before you. If the thing that comes before is okay. Drama here on the home front. 3-year-old is very emotional right now. Okay. So if the previous thing is one of these, then we take NFA state star previous state equals this mess. Previous state operation. Previous operation is this, then previous state is non-greedy equals true. And now there's no processing to done. We don't add anything to our list of things to process. It just modifies the previous thing, which means 1. This code all goes away, which is nice. This 1 or more is never going to be worked out until I sit down and think it through. Let's just see if that works. A question mark. 0 or 1. Go to 1. In 1, match an A. Either state can accept. So that's correct. Question mark, question mark. We first try to accept, basically. We can't accept when we go here. Look for an A. What if we put B in, make it more interesting? 0 or 1, go to 1. Match an A, go to 2, or we just go to 2 if we can't find the A. Okay. Question mark B. 0 or 1, we go look for a B. If we can't find a B, then we go to A. If we find an A, we go look for the B. And only after a B can we accept. That looks correct.
Wait, please.
A star B. Go to 1, look for an A. If we find an A, go back. If we can't find an A, we go to 2 instead, which is a B, which is our accepting state, which is correct. So I think this simplifies my processing a lot, doing that test at that point in the program. Here, we go to look for a B. If we can't find a B, we go to A. If we find an A, we go back. Only B can accept. Okay. So those all look right. So, plus is my biggest problem. Match A, go to A. Okay, so something in our code is still wrong, but I like this better than what we had before. Non-read modifier, otherwise just a 0 or multiple test. The current Patch all of the previous stuff. Previous. Next is our insert. Move the current and advance. This is so close. I think I'm just missing one little link of things pointing to things. This is all right. This is all right. We insert this. We delete the current thing, which is right. And our previous thing remains our previous thing. Next equals fragment, insert current new fragment, fragments, erase current, delete current fragment, and then advance. Leaving previous. So we had A as our previous, and A will remain our previous in the next loop. A plus. Then we get B. And B is not one of these, so it'll pop out. Pulls a new state. Hatch. E is the thing we're modifying. So that's A. Switch. Stack. Stack. What is going on with this stack here? Okay. One or more. The current state, which is the plus sign, needs to first try to go to the previous state. The previous state points to the current state. However, the previous thing needs to remain where it is. And previous frag clear. Previous frag out dot push back. Current start state from Q out to 2. Then we do next equals cur next plus plus. Then we can erase cur, delete cur. It's not defined. That's fine. Okay, we hit A. Unentered at 1 or more. It tries to get back to 0 to try another A. If it can't get 1, then goes to B and it accepts. Hey, is that right? Come into A, go to 1. It tries to go to B. If it can't, it goes back to A until it can go to B. Okay, I think we've got it fixed finally. Whew. I think that's correct. Alright, so we go back to one of our bigger ones, where we were inserting strange things. Yes. Like this one. Okay, let's put this back the way it was. Plus and star. Okay, so these are all greedy operators. So we get to here, we try to go to 2, looking for an A. If we can't, we go to 3, looking for a B. Question mark is 0 or 1, so I can skip the A and go to B, that's fine. Okay, so that's 0 or 1. 1 or more of 7, yep, goes to 8 and 7 and 8 until we can't find any more A through Z's. Then it goes to 9. 9 says 0 or more white space. So we'll first try to go to 10 and grab white space until it can't grab any more white space, then it'll accept. Okay, so that's all correct. So let's make this non-greedy. If we get here, we first go to 2 looking for B. If we can't, we go to 4 looking for A. If we find an A, go back to 2 looking for that B. Good. This one, the plus, this is the non-greedy one. So if we come here looking for 1 or more, 9, which looks for get to 7, 0 through 9. Here's 0 through 9. At 6, it wants to go to 7 after that, which is anything which is not A through Z. And let's have at least 1, so that plus so far is being met. So it goes to 8. And 8 says, try to do anything else, go to 9. And if you can't do that, then go to 7, which is back to here. So it'll try to get out of this 1 or more as fast as it can, and will only fall back if it has to. So if we go to 0 or more, then it's 9 or 10 until we run out of white space. So that looks correct. Now we put the non-greedy modifier on the last piece. We come down into this, come to 9. 9 says 0 or more. It tries to pass and accept. Otherwise, it goes to 9 to 10, which accepts these and then bounces back to 10. Yeah. Okay, so we just added non-greedy modifiers and fixed a long-standing bug that never showed up in my regex. At least not the way I was using them in a limited scope. So that all looks correct. And all I had to do was stop trying to copy the code and instead think through the actual process of what's pointing at what and what gets deleted and left alone. You kind of have to think about it for a while for all those things to become cemented in your brain enough to code it out. So, added non-greedy modifiers to this to the NFA. In doing so, found that plus had copied the reduce code from star, had to rework that branch of the switch. This fixes the long running bug that I never tested, ran into during normal usage. Basically, my regexes are matching things in a way that you can tell, so then it was a plus. Okay. In other words, I wasn't going to leave an empty string. So if I look at the bay.bay, where's the plus, right? This plus behaving like a star didn't make any difference in the way it behaved. Because anything else would match a longer string. Unless we had one of these, then it would match this, and then it didn't matter that it was a plus. What else was there? Those are escaped. Yeah, and then plus new line character again. I was never going to have an empty pattern in my file, so this plus sign didn't matter. So, good times. Okay. Added non-3D modifiers. Fixed bug with plus with one or more operator. Okay. Boom. Journal. Next thing. Oh, we should have marked that. Okay, 5:30. Do we have time to add anchoring? Anchoring means, let's see. Anchoring happens right before alternation. So let's go to this thing. Okay. Escaped characters, we handle up above during the scan. Bracket expression, we happen during the scan. Grouping, we handle chunks of it during the scan. That's fine. Cardinality, we handle correctly. Concatenation, we handle correctly. We skipped anchoring before. We need to do it now. Alternation. So we need to reduce anchoring fragments. This will be a whole new fun adventure. So let's just get it stubbed in. Let's talk about what anchoring does. One thing we can do is say we want keywords. Let's see here. Let's maybe get a scratch buffer instead. We want to say we want the start of a line. So maybe we're doing a config file, right? Thing equals other. To match this, we would want to say a pattern that says we want to match anything at the start of the line, A through Z, a certain way. We want to match anything at the end of the line differently. Okay, so maybe this is a key, this is a value. The important thing is these don't interact with new line characters at all. So this literally says if this is the first character in the file, or first character in the text, or if the previous character was a new line, this will match that. So it will never, the word more will never match either of these. This one will match thing because it's at the start of the line. This one will match other, and neither of these will match more. So if you're going to do line-based processing, this is a very good way to do it. And maybe you can make it a little bit more fancy with like \s star \s star, saying we don't care about leading and trailing white spaces. And maybe even have another thing like a modifier equals, so like that a bit, equals anything that is not the start of the line followed by A through Z followed by anything which is not an end of line. This one gets more. That makes sense? So anchoring says it has to be at the start of the line, or it has to be at the end of the line, or it has to be in the middle of the line. It can't be at the ends. So that is a useful tool for building line-based processing tools. If we wanted to make like a simple config file, key value pairs on a line. So it's actually not that hard to add. Just have to decide. I'm about out of time. So next week, now that we have NFA compilation done, let's put this into the code base in the journal. Let's put it in the journal. We did not add anchoring, so stream stats. Let's see. Next week will be the 16th. There's still the old task here. And then so anything looks like this. Here's our string. We match a key as being on the start of the line, value as being on the end of the line, and the modifier is not being at the beginning or end of the line. So that's what we're going to work on next week, and it won't take us long. Which means we can start on the NFA to DFA transformation, which is sort of the last thing before we generate code. We're going to generate a lot of text, but we need the DFA done first. And where we'll spend a lot of our time is the generated code is going to implement a lot of things in 2 or 3 different ways. And it'll be for us to be able to test speed at the end. So ultimately, we're going to make a parser of something that I can get an awful lot of, probably JSON. We'll make a JSON parser. We're going to download a ton of JSON from somewhere, and we're going to see how fast we can parse it all. And then we're just going to keep changing different compilation options of all the various types of code we generated and see what the fastest way to get through it all is. I have a lot of ideas about where those things are going to happen and how much they'll save. Well, not how much they'll save. I know that some of them will save save some time, but will it be a meaningful amount of time? That's sort of what we want to measure. So I think that's the plan. NFA's just about done. We just need to add anchoring and we're done. So thanks for joining. Hopefully you learned something about building an NFA from a text pattern. And yeah, hopefully it was entertaining, or at least educational. Next time we'll finish the NFA off and start building our DFA. You'll see what the differences are when we build it. So have a wonderful evening and a nice long weekend. Next week we'll start back in with the game development, and we'll do like a half day of code metrics. We want to do different code metrics than just lines of code. Write a script for it. All right. Thanks a lot. Have a good one, and talk to you later. Bye.